Thank you so much. All right. So today we're going to start with Android uh, application platform and an application if you want to build. So what we have to follow, what is the life cycle which is to be followed for building an application. So this is with an agenda of today, right? So we're going to talk for this. So this entire session will be mainly talking about creating applications as well as activities, where it will going to talk about the application manifest file and then creating applications and activities. And there should be some architecture pattern which always we should follow whenever we are building any application. Okay, so that what are the different architectural patterns which are available with us, and what we have to talk about, so that we'll be talking more on one of the pattern, so which is called as model view controller, so MVC pattern, right? So similar to that, there could be a publisher subscriber pattern, right? So kind of those patterns will be available, but here we'll be mainly focusing on one architecture pattern, which is called as model view controller. And then we'll be talking about the review of other architecture. There are different patterns and the architectures which are available for building the applications. So what those are, we'll be talking about them. And then the Android application lifecycle. Right? So to build an application, so the what could be the entire the life cycle of an application will be followed here, right? So we'll be discussing majorly on that. Now, before we proceed, right, just to recall from the previous session, right? So there are the software platforms and mobile development. So we just had the discussion on this, where we spoke about portable devices, which could be any handheld device, which could be majorly mobile phone. Nowadays, we will be using an IoT, which is an Internet of Things, where we connect the things to interact with themselves and get the data and process the data. And Raspberry Pi as a processing unit, where it can take data, process and send and do some activity on that. So which is a Raspberry Pi or full, these are all the major full computing systems, right? So they just doesn't mean they just only work with certain application. So they are being modeled nowadays had to become more generous and more general purpose operation. So in order to do that, there is something which is required from the mobile device. So the mobile device will work with an application, but the application to run will require an operating system. So we'll be using a mobile operating system, which is going to majorly does an operation or acts as a intermediary between your application and the hardware, right? So where it's going to manage most of your things, so which is are there on your system or in your application, sorry, in your mobile phone, including your hardware, the applications, as well as your memory management, right? So the various the built-in applications or deployed applications, right? The sensors and the connectivity, because that's the mobile phone is majorly does the job as connecting to the network, right? So it could be through Wi-Fi, it could be through Bluetooth, it could be through cellular network. Okay, so that's the job of the operating system, which the mobile operating system will take care of, right? So these mobile platforms will have a different the ways of connecting with different architectures will be there, different frameworks will be there, right? But all of them will be having the main purpose and main aim, right? So it all aim to run the applications more reliably without giving any trouble, without causing any delay, right? So manage resources on your mobile devices, such as your CPU. It could be your memory as well as the consumption, battery consumption. At the same time, have a feel and look of the application such a way that the user interface should be enabled for you to access them, as well as connectivity, that is again a network, and the features, utilizing the features of the features of the device. Okay, so then we were just went on to understand the mobile operating system and the different software stack which is followed in the mobile devices. Okay, and then what are the key takeaways? That the mobile device is a mini computer. Okay, so the main thing is that your mobile device is just not only a device which can carry the signal and just perform you or give you an access or connectivity. So your mobile device is more of now has become more a computer itself, where you can do everything from your computer, right? So there's no restriction on that. What you cannot do from that, you can have there's everything what you do in a laptop, you are able to do that everything on your computer or on your laptop. Sorry, on your mobile phone. The operating system and the platform architecture decide how the applications run and how the battery resources are saved. And then we just spoke some of the things about the development tools and the platforms, right? So which is going to help us to build yeah, the applications, ensure that they are working properly, right? Ensure that they doesn't have any bugs in it, right? So all these things will be done with the various tools and the platforms, and what are the different languages has been used and supported by the devices, right? Because whatever the application I want to build, right? So I have a logic with me, but the logic has to be converted into reality with the help of a programming language, right? So that's what are the different programming languages which is supported by these platforms, right? So convert the developer logic into operating system compatible applications. So then the simulator versus emulate, right? So there is a user interface testing which can be done through simulator, but hardware mimicking and getting a real feel of a hardware. The feel of a hardware to get that feel and to ensure that the application can run in that hardware. So we'll be using an emulator before deploying that application, right? So the emulator will mimic your hardware, right? So that's where it's going to be standing alone, right? So it stands first. And SDK, the software development kit plus the development environment will provide a lot of APIs. The built-in libraries are there. Built the tools are available for building your application, and as well as debugging support when you want to build an application, so that it will go through a particular process, right? So we call it as a life cycle of it. So application development life cycle. So we're going to start with an idea, right? So which will be conceived in your thoughts, and then that thoughts is converted into a design, right? So that you're going to have a proper architecture for them, and a design document is been built, and you're going to identify the interfaces for them, how the and the connectivity between them, how the data sharing will happen, and who will be communicating to whom, right? So all these things will be decided, and you're going to have a clear picture of that, and through which you're going to have go for a development. Right, so the development will be done through a programming language which has been there as a design document, will ensure that what has to be done, who is going to call whom, and all the things are decided. So from there it goes for the testing. Testing will be carried out to ensure that all the requirements which has been stated by the stakeholders are being met, right? And they are working properly, correctly, right? So all these things has been tested. Once it is done, then we will deploy into the system. So once it is deployed, so then it start working and we get the real-time data, real-time feedback on that. Then that will next phase will go on for maintenance. It is nothing but a kind of that the application running without any problem. Just will keep supporting them at the same time, keep enhancing the features of that. So all these things will be done through it. The major takeaway from that is the applications are built using the ID, right? The plus SDK plus languages. So these three things are required, right? So the development environment, right, and as well as the development kit which is required and the language. So tested, all of them which has been used in order to build an application will be tested using a simulator or maybe an emulator, and definitely that will be ensured that everything has been verified. So then we will be delivered through a structured lifecycle. Right. So with this agenda, what we discussed in the previous session, so we are just moving ahead to understand today what is a mobile platform, historic perspective. So in the record lectures, all these things was there. Please go to that and refer that mobile platforms, Android architecture development platforms and development tools, programming language, simulator and emulator, and then platforms generate for that. Right. So let us go ahead and try to understand building an application. Right. Android. So this Android is an open source, is a available for anyone to build their application. So there's no any constraints and there's no any money involved in this, right? So you can build your own applications. Only thing is that you should know how do we use that, the IDE and the SDK for them. Okay, so it's a purely Linux-based kernel which has been used to build this Android operating system. Okay, so it is a Linux-based mobile and embedded operating system, which has been completely built to support both the the uh, a huge range of portable devices and the resource constrained devices. Okay, so this provides an architecture which is said to be a layered software architecture, which consisting of the Linux kernel at the bottom layer and then native libraries along with the runtime Android runtime libraries, application frameworks for building your using them, as well as the your own application, the user applications which has been built. So then the application development is a primary job which has been mainly focused. Okay, so using the language, there are two languages we will be using in the Android. Either we may go for the Java or it could be a Kotlin with additionally supporting C or C++ frameworks, which are also possible, where you have a system level or performance critical components to be built or to be integrated. So that can be done here. So which offers this the Android will give us a comprehensive SDK, right, which is a software development kit, which comes with a lot of built-in tools. There are debuggers are there, emulators are there, and device management utilities also. So to mainly to ensure the control access to hardware, the security and the lifecycle management. So these applications must mainly declare its structure and the requirements to the operating system. So uh, where to have this declaration mechanism, it's a formal way of declaring and telling the Android application or the operating system. So it has been implemented through a manifest file. So which acts as the contractor. It's going to be between the two entities. One is the application as well as the OS. So it is going to give the interface so that you are connected to operating system. Okay, so that is what this Android manifest file will going to be acting as a thing. So which is said to be a bridge between your application and the Android operating system. So let us just go through this structure or the evolution of this Android, right? So the first ever Android version was released in 2008. Okay, so the first commercial release and basic where it has uh, basic integration was with Gmail and the calendar and the maps integration. So there was just gave the name as like there is something like alpha coding or just Petit 4. So just they gave. But the next thing is that 1.5, the version 1.5, Android 1.5 was named as a cupcake in 2009. So the input, the added the first on-screen keyboard, right, moving away from physical layer. Okay, so Android added the first on-screen keyboard for that and allows you to type it. 1.6, it has been named as Donut. So the variety allowed Android to run on different screen sizes and resolutions. Right. So earlier there was a restriction on that, and it has been enhanced so that you can run on a different resolutions mechanistically. And then 2.0 and 2.1 is said to be the Eclair. So the Eclair 2009, in which it has been stated, and it is a navigation. It's been introduced with the Google Maps, where it can clearly say that this is the way you have to move on, right? So that means it's going to be giving more clarity on your transit, saying take left or take right. So just giving every direction, so every turning. So then it has, and the next version of that has been 2.2, which is called as Froyo. In 2010, it has been introduced where it has a massive speed boost with the help of a JIT compiler, and which has been uh, enabled to get connected to a Wi-Fi. 2.3, which is called as Gingerbread. So 2010 is a, yeah, so where it supports gaming, right? So need for communication also it has been improved. So with the help of a sensor support, so and NFC, the payment, like so to have a payment so that I can get connected to a device and I can make payments. So well, that was a thing which is major incorporation in gingerbread bread. So third one is honeycomb. So 2011, so where it has come with a tablet, a version made only for a large screen, so such as your tablets or your desktops. So the version 4, so the ice cream sandwich, 2011, so which comes with a Unity, so combine phone and the tablet software into a single design. 4.1 and 4.3, which is a Jelly Bean, which has been introduced in 2012. So, which comes with a very smooth interface, and the Project Butter made the touch interface fluid and lag free. So that the application version. 4.4 is a KitKat version, so which has been key Lime Pie, so 2013. So efficiency, which has been optimized to run on low end phones with very little memory space of the RAM. So 5.0 and 5.1, which is said to be Lollipop. So lemon meringue pie. So 2014 is here introduced. So which has been designed as a new Marshall material design. Look and the move on the ART runtime. Uh, the version 6, so marshmallow, so macadamia nut cookie, so security, so introduce runtime permissions, maybe for accessing GPS or maybe of mic or in it is when it is needed. 7.0 and 7.1, which is called as Nougat. So which allows you to run the applications on a multitasking. The split the screen mode allowed two applications to open at once. 8.0 and 8.1 Oreo. So 2017 is the year introduced. So background control was there. So limit what the applications can do when they are not in the use. So that is, say example, an application is requiring a certain brightness, handicap, permissions. So if the application is not active, so that automatically the internet connectivity for that application and other things will get discarded or disconnected. So kind of those things. So nine, it is a Pi, so which has been allowed with AI, adaptive battery, and AI to save the power based on your usage habits. So Android 10 so comes with a privacy mode boost. Uh, Android 10 so which comes with a privacy scope to storage restricted applications for seeing all the audio files. 11 communication was introduced, bubbles and group chat notifications. Android 12 was a personalization, so where you can group it, material you, the OS color change based on your wallpapers. 13, which comes with the granular privacy, so where permissions for specific photos or videos rather than all the files. Android 14, so upside down cake, so customization, so deeper lock screen edits and ultra HDR photo support. Android 15, so vanilla ice cream, so which 2004-24, so where hardening added private space. Here it's something like a virtual space for uh, maintaining application. And then Android 16 is intelligence, which is shifted to a June release cycle, desktop style windowing. As well as to Android 17, so AI, agentic AI has been introduced along with the full integration of multi-model Gemini Nano was part of that. And this is an architecture, the Android platform architecture, which already, as we said, so we'll have a Linux kernel at the bottom layer, and then you'll have a abstraction layer, HAL, the hardware abstraction layer. So above that, you'll have a native C, C++ libraries, and then at the right you'll have a Android runtime, which possibly, and then you'll have our API frameworks, and then at the top it will be a system applications. Just a minute, I just come. We phone and charge charge Sorry. All right. So at the bottom layer, so which is said to be a Linux kernel, so which has different drivers, which supports you to if you're building an application which requires support of audio or the display or camera, keypad. So what are things is required? So all of them will be enabled for you. Just use those libraries for your application. So then the abstraction layer will say, help you out to in order to get connected to those drivers easily with the help of these drivers, which are set to be audio, Bluetooth, or anything. So it has a set of the libraries which are said to be native C or C++ libraries are built to enable you to build those application or transform that application or into a required format. So WebKit, OpenMaxAL, or libc, or media frameworks, or OpenGL. So various things which you want to do from your application so that you can have all those things together. So ultimately, to ensure that this application can run anywhere, so it requires some the runtime library. So it has a now Android runtime, but earlier it was the Java virtual machine, so which was there. So, but now it has been replaced with the Android runtime. Okay, so which includes the core libraries also. At the above layer, which supports you the frameworks, right? So which has the entire application. So we'll have four components. One is content provider, your activity, and then broadcast receivers, and then intents. So all these things has to be managed, and your activity, your location, the package, notification, all those things which is required, it will be managed by your frameworks, right? And the top layer is a system applications which comes with a dialog, and it has default applications which has already been there, so you can utilize them in order to have a communication with your application. So the application execution model, so which is purely there are multiple ways. So the component based architecture. So where you traditional programs that start with the main function, but whereas an Android application is a collection of essential components. It is not that we will be having a main and just a system-driven execution. So this Android application, the operating system, which is having a system controls where the entire applications will be controlled by. So it instantiates the runs the specific components only when they are in need, not unnecessarily, or it will not be run every time. And the entry points, there is no single entry point. The system can start the application through various pathways, such as user tapping an icon, a notification arriving, or another application requesting the data. So resource usage, so one application can make use of other applications components, right? So such as like your camera required for other things, so to access the library, or say a simple example. So WhatsApp is an application, so which requires to capture the photo. So the photo can be captured to another application called as camera. So we have to integrate it. So resource utilization. So kind of that. So there are modern development tools, so which comes with the different languages and the packaging, right? So the primary language we're going to use is Kotlin. So it is a industry standard language right now for most of the Android applications which has been built, chosen from its safety as well as the rich set of features which exist in that. So there's a build artifact. So we'll have the bundle, the .aab file will be there. So Android app, the bundle, so which can do that. The code and resources are compiled into an application bundle, not a direct APK there. So dynamic delivery, so the Play Store uses the bundle to generate an optimized APK specific to the user's device, reducing download size. Composition, an application consists of Kotlin classes, the logic and the behavior, resources, non-code assets like managers, the images, the strings, and the UI definitions. So core application components of any application you build. Okay. So as I mentioned, there are four components are there. One is the activities. The second one is the broadcast receivers. The third one is a content provider. And the fourth one is a services. What is an activity? So an activity is a screen which is appearing to you on the application. There could be multiple screens we create. We navigate from one screen to other screen, right? One entire screen is called as an activity, right? Represent a single screen with a user interface in that. So where activity performs whatever you do it. It may be, say, example, login, right? You have username and the password, and there's a button to authenticate. So it is said to be an activity. And then there's a broadcast receivers. So what they do, somebody, say, example, in your phone, there is an announcement. What is that announcement? Possibly somewhere, sometimes you'll get battery is low. Now, this is a broadcast message for every application or every component of your device. Now, what will happen when these things will appear? Who has to respond for that? Is that every application, every component has to respond for that? No. Or what we have to do? So who has to respond? Now, there is a thing that there are people who have registered for that. Okay. So they have to respond for those broadcast messages. Right? So it is going to, the message has been broadcasted. So we have registered for them, we're going to receive. Say example, brightness of a screen. Now when the battery is low, automatically the brightness of the screen will reduce. Right, because it requires a lot of memory. Automatically Wi-Fi will be turned off, your data will be turned off. This is what we call as broadcast system. Content provider, right? So they are like, they provide the data for your application, for your activity to carry out. Say example, contacts is a content provider where it gives you, you want to dial, you want to call a person. So that contacts has that number. So the contacts now will act as a content provider for you. Right? So your contacts will act as a content provider for your WhatsApp. Right? Where it's going to take all the contacts and it's going to display the name on your WhatsApp status, right? WhatsApp list. If it is saved, then only the name will appear there. So that means that is going to act as a content provider for your WhatsApp. Photos, the gallery. So that's a content provider. Services, right? So that means there could be a certain things which will be keep running at the background. Right? So some application or a service or an activity which is running is called as a service. That could be running in the foreground or it could be running in the background. So when it's said to be background, that means it won't be visible, but still it will be running as an activity at the background. So when it is running, it is carrying out its task, continuously monitoring the temperature of your device or continuously observing the battery usage, right? So maybe your date and time. So kind of those things are continuous in nature. So they will be running. Right? So the kind of those things will be running, which are set. So that means what are the four components of a application, Android application: activities, broadcast receivers, content providers, and services. Please remember this as a very, very important question. Okay. The system contract, introducing the first thing, Android manifest file. So the problem, the Android system uh, may not be able to scan through all your files, the Kotlin files, to find your activities or services. That would be too slow to insecure. That means I'll write a one big file which has a lot of code written in that. So thousands of lines I've written. Now, when I've written all these things, what activity, what service, who is content provider, to identify everything from that file itself will become very difficult. We will not be able to understand that, or it takes a lot of time to understand. So we require somebody who can tell that operating system, yes, this is an activity or this is a service which are there in this file. Okay, so that job is carried out by this file, which is called as manifest file. Okay, so this is purely an XML file. So we just use an XML tags there to represent those activities or services, whatever it is required. Right? There's an XML file located uh, at the root of the source set. Okay, so it acts as a mandatory contract between your application as well as your. So as I said, the Android manifest file is a bridge between your OS and between your application. So hey, Jive, backlog, backlog. Okay, so what's the role of this? Before the application even starts, the system reads this file to understand what that things will do, what are the components of your application which have been uh, listed, what permissions the application is required. Okay, so what hardware features are there are needed for your application. So these things, like for example, I want to use a camera. So camera cannot be directly accessed. We require permission for that. Okay, contacts cannot be accessed. Or I just want to make use of a calling feature in my application. So I cannot use because that's an external entity. So I require a permission for that. So I have to ensure that what permissions, right? And what are the features I need to use, the hardware facilities I want to use there, so that I have to indicate, right? So all those things will be listed in this manifest file. Okay, so if you look at the anatomy of the manifest file, the structure of that, right? So we'll have a manifest where it consists of the root element, okay, contains the package name, and then you'll have application, what you are, right? So it's an element, a container for all your application components. It also holds global attributes such as your application icon and the theme also. They're all set, most of them will just set it as default, right? Unless we go for a real-time thing which is to be changed. So then we don't. Okay. So then it's going to start with an activity element, represent screen. So in that screen, what is the thing? So the intent filter. So inside the activity tag, we define intent filter. This tells the system how this activity can be started. That means, so there are screens are there. We may write 10 screens, right? So when you log in, which is the first screen which should appear to us, right? So we may one of them as this is a starting activity. From there, it may have a multiple navigations, but to showcase that this is a first activity or this is a first screen. So we'll be using that as a, and then we'll have one more tag which is called as users permission. So this lists the specific user permission required for your application. Okay, what are the three major jobs the manifest file will do? As a developers, we edit the manifest primarily for three reasons. One is for the identity reason, for the permissions, and for registration. So defining the application name, icon, and the theme, we have to use the manifest file. Asking permission from the hardware, so the hardware as well as the operating system, to access certain features, say such as camera, or maybe the internet, or GPS, or Wi-Fi, or a telephony service, or SMS service, right? So anything as such, we require permission. So we'll be using this as a permission stack. And then registering. So you screen the activities, number of activities, and the each activity, which is going to be a starting activity, right? So to tell that, we're going to use this registration. Requesting the system permissions, right? If your application needs outside resources, right? Say example, internet or hardware. Okay, so certain things you need to declare it here. If you target this tag, if you forget this, OS will block the features for security. They will not directly give. Say, always manifest file. So you'll have this tag uses hyphen permission with the Android name is equal to android.permission. It's a default thing. When you just type one letter, automatically all the things will come. Okay, there's nothing that you have to type everything. So that will be there, which what are the permissions you require, all of them will be listed there. Okay, so identity. So it's a icon. So at MIP map the IC launcher, at string app name, at style theme dot my first application. So that icon label and the themes which has been mentioned. So registering activity. So which is set to be the main activity, right? So we'll have activity Android name dot main activity. So this is set to be this activity is set as a main activity, and this activity is set to be the launching activity. Okay, so we'll be selling that. With the filter, we say that this is a main activity, and that means when you start the application, this is a first screen which is going to appear to you. Okay, so this is so with this is a settings activity, a settings tag. What are the key takeaways? Mandatory. Every Android app has a manifest file. That's only one manifest file will be there at the root of the source. Explicit, if an activity is not in the manifest, the application will crash when trying to open it. Obviously, it has not been declared inside your manifest, that will never be opened because there's no interface only. There's no connectivity to the application, the activity itself. Secure, so the permissions which is required, you have to obtain the permissions without which you cannot access that. The structure, so we'll have this as a major structure or a primary structure, root, permissions, global settings, and then screens. Right. Next thing is, so building your first application. So using Jetpack and Kotlin. So key points is that the goal, we will create a working Android application from the scratch using project template. The approach, we will be using modern Android development standards such as Jetpack Compose, not the XML approach. The outcome by the end of this session, so you'll have a customized app running on your screen. So to do that, first thing is that we have to have a Android Studio. So must be installed and updated to the latest version. Ensure your computer meets the system requirement. That's most important. This requires RAM and the disk space. Okay. So minimum of because to run your Android Studio itself, it will take a lot of memory. So at least 8 GB, minimum 8 GB of RAM is mandatory in your system. If not, you cannot run your Android Studio. You can, but it's not that you cannot run, but it will take a lot of time and it will block it. And the knowledge base is required. So basic Kotlin, familiarity with the variables and the functions. Jetpack, we will use this for the UI user interface instead of XML here. So what will you build? So an app that lets you customize your introduction. So here's what the application looks like when you complete this code lab. So except it will be customized with your name. Okay. So first point is that, so create a project using a template. So phone and tablet. So empty activity you want to choose, right? A message that looks similar to this informs you when the project setup is created. So this is how the code looks like. Okay, so you'll have a manifest at the hierarchy. It will show you manifest Kotlin. So there'll be three of them: com dot examples dot greeting card, right? So Android test and test, and then resources will be there, resource folder, and generated will be there. Okay, so this defaultly will exist when you create a first thing. Okay, so you have to go for this project source files from the drop down menu. You can browse the files in the same way as anything. So you'll get this main activity, component activity. .kt file will be created. There are some automatically generated. It's a field default thing, so you need not to do anything here. Okay, so that background, everything will just has been set. So specifically on create and the set content functions. Okay, so now greetings function will just create function. Fun means it is a function. Greeting is the name of the function. So name string modifier is equal to modifier. So where you're going to say text hello, the name, whatever the name you wanted to give, and modifier is modifier. So add composable annotation before the function, whatever you want. Add composable function names are capitalized always, and see this: the composable functions can't run return anything. That means these functions cannot return anything. So this they will perform their operation, close it. Update the function. So you can say hello. Hi, my name is, with the name you can specify, Android modified. So which is now in the preview. Okay, so update the greeting preview function with your name. So then rebuild and check your out your personalized greeting card here. So when you set show background is equal to true, so composable fun greeting preview, greeting card theme, so greeting gibbon, right? So this is how it's going to be appearing to you, right? So what are the tasks to be completed? So enhancing the existing greeting card so that you can do that. In the existing greeting composable, add a background color of your choice. Add a padding so text does not touch the edges of the screen. Okay, do not change the greetings text or app logic, so only improve the UI settings as you want. Rebuild and run the application to verify the changes. Okay, so you can just go through this if you want. There's a link provided for you so to understand. Why I'm not showing, you might ask me, sir, why you are not showing the demonstration. Still, I have a problem with my system. It is not able to deploy that properly. Maybe in the immediate next class. So with another laptop, I'll just show you the demonstration of these things one by one as we proceed accordingly. So then, as I said, architecture pattern. So for because any application you build, so it has to follow that MVC pattern, more or the pattern. So one of the pattern what we have used here is model view control. So before we write the complex applications, we need a plan to organize our code. Okay. So the most old version of that, or oldest pattern is that MVC, model view controller. So it separates your code into three distinct roles, right? So what is being done as one is your browser, model, view, and the controller. uh, in a simplest way to define that whenever you're in the organization, we say this role has been responsible for this person, right? So that we just segregate accordingly and we define this role. Yes, this role has been completely handled by this team and kind of that, right? So, so this diagram shows you very well the model view controller. So where view as a customer, model controller as the waiter, and model, right? So that's the one which is going to does your task actually. So controller is the one who's going to just integrates everything and just gives interfaces among all of them. Okay. So what happens here is it the view, the customer will come and look at the menu card. So menu will show that these are all things are there. Right? So based on that, he will order this. So when you order this, that will go to the controller will take that, the waiter will take that and go tell to the model. So he will prepare that data, what is according to that, and process and gives you food. So that the controller will carry that data and provides to the customer. So your data classes and databases, which can be model, right? So view the layout, how does it look like? Okay. Controller, the activity is your thing. So the flow is the user clicks a button. Activity, here's the click. The activity asks the database for fetching the data. Activity updates the screen with the new data. So why we moved away from MVC? So that's Android controller, right? So it's tied to the screen, right? So if you're rotate your phone, the Android OS destroys activity and recreates it to fit the, because it has to match the resolution and the size of it. So definitely it has to do that. When you do that, definitely there is a consequences. What is that? The first thing is data loss. What are the data which I had earlier? So it will get erased and you're going to have a change in the data. So the God object, since the activity handles UI and the logic, so it becomes huge. So 1,000 plus lines of code. So it creates a mess that is hard to test and as well as to maintain. So the modern solution is that model view model. Okay, so where instead of that controller, we will be having a view model itself. So they introduce a new component called the view model here. So what it does, model as a still on the data that will process the data. View user interface. View model is a smart control. Okay, so that it just it survives. View model lives outside the visual screen lifecycle. If the user rotates the screen phone, the activity dies, but will always try to hold the data. Separation. So there's always view will handles only looks. The view model handles only the logic behind that. So reactive, the view observes the view model. So when data changes, the UI updates automatically. Right. So same thing here. View model. So whatever it is there, I just said. So this one, I have this data, so that I'll just remembers you and just try to work smartly rather than the customer now the waiter. So I'll have an application which can remembers your preferences and try to do things for you. Okay, so the class main activity component activity, so the data is stuck inside the activity. So look at the count variable, so it is inside the main activity class. When the activity is destroyed, the variable is destroyed too in the MVC. Rather here the create a model view, this class stays alive even if the screen rotates. Some of the other architecture patterns, model view presenter, okay, organizing the overloaded activity, the historical context. Okay, so MVC pattern, the activity had to handle everything, the user interface and the complex logic. Okay, this created a monolithic activity here. So the single file that was too large to handle every logic over there. So we require something to overcome that. So with the help of a MVP model view presenter. So the key concept is separation. We move all thinking and logic out of the activity and into a separate class called the presenter. The goal is that the activity becomes passive. It should not make any decisions, only follows the order. So just look at that as a TV remote. Okay, the TV doesn't decide what to show. It just displays whatever the remote control tells to do. So that is what the presenter job will. So this model will handle the data as its network and the APIs and all other things. It just view the activity or the fragment, or it is a extremely simple role. The job, it forwards user clicks to the presenter and waits for the commands. It contains no logic there. The presenter, the brain. So the plain a class, right? So it could be a Java class or it could be a Kotlin class. It receives the input from the view. Okay, so that somebody's remote thing, which is click the button, decide what to do, and commands view to update them. Right, so just takes the input and just transforms it to the thing. So he will decide what to do. The big movement is that, so testing, because the presenter is a separate class with no Android code, we can test the logic easily. The problem is that the tight coupling. So the presenter and the view are completely tied one-to-one. So it is very difficult to separate them. So life cycle issues will come. So if the screen rotates, the activity is destroyed. The presenter loses its connection again. So it has to leads a lot of app crash and things like, which cannot be handled manually. So the solution is that this difficulty led to MVVM, where the view model can survive screen rotation automatically, making our applications much more stable. Okay, so this is the difference between MVC and MVP. Right, activity. So as I said, an application is built using set of activities. In the Android, so an application doesn't run. It moves through specific states managed by the operating system. This is called a state machine. Okay. So this controls these states to manage battery and the memory efficiently. If an application doesn't visible, so Android puts it to a sleep or shuts it down to save the power of the activity. So the job shift analogy. So how is it? Think of an activity like an employee clocking in for a shift. Okay, please. Preparation. So you're creating the application. So you arrive at the office and set up your desk. Clock in. So you are at your desk, visible to the boss, but haven't started typing. You started working. You are actively typing and interacting with the customers. Break time. Paused. You are still at the desk, but distracted by a phone call. You can't type right now. Clock out. So you leave the desk. You're still an employee, but you aren't working. Fired or quit. So destroyed. You leave the company entirely. Your desk is cleared for the next person. So these are the states. So that means created, started, resumed, paused, stopped, and destroyed. So activity life cycle with the diagram. Please note this. So this is very, very important. Whenever you create any application, this is how it's going to navigate the transitions between the stages of the activity life cycle. The activity class provides a core set of 6 activities. One is the callbacks: on create, on start, on resume, on pause, on stop, and on destroy. Okay, so an activity is launched. So that means on create. Okay, so they created, but nothing is started. So once it starts, so it's just running, right? So its activity is running, right? It goes on. Maybe if you say you just started an activity, suddenly you get a call. So that means your activity is paused. So once it is paused, so your call is done, and then you can resume back. So when you resume back, activity will still running. But suddenly you got a call and the call is very emergency, so that you just close application. So that application is killed and it will go back to the on create state. Okay, so on pause. So or the thing is that it is going on activity, so there is no to pause, and then you just stop it. I just don't want to do that activity. I was just playing a game, that is sufficient. I will close the application. So then on restart. So you have to restart the application once again to use it. Okay. Otherwise, I just activity is finishing. and destroyed by the system. That means this is a kind of that doesn't mean that application is removed from that. So that entire work of that application is carried completed now. I'm going to remove from the system memory. Okay, so that's what undestroy is. So that once you do, activity will shut down. So on create, so application is initializing, so loading all the layouts for you. So tap the application icon. So you see the YouTube logo. The application is setting up the video player. On start, the application becomes visible. So video will load. You see the video thumbnail and the loading screen. So it is visible, but the video isn't playing yet. On resume, the application is interactive and active. Video plays, video starts moving. Sound is on. Just a minute. Hello. Ama. ಹೇಳಮ್ಮ ಇನ್ನೂ ಇಲ್ಲಮ್ಮ ಹೇಳು ಇಲ್ಲ ಹಂಗೇನಿಲ್ಲ ಆರಾಮಿದ್ದೀನಿ ಹೇಳು ಹ್ಮ್ ಓಕೆ ಹೇಳಮ್ಮ ಶ್ವೇತಾ ಮ್ಯಾಮ್ ಕ್ಲಾಸ್ ಟೀಚರ್ ನನಗೆ ಹಾಕಿ ಅಂತ ಹೇಳಿದಾರಂತೆ ಬೇಜಾರಾಗ್ತಿದೆ ಸರ್ ಇಲ್ಲಮ್ಮ ಅಲ್ಲ ಆಕ್ಚುಲಿ ನಾನು ಹೇಳಿದ್ದು ಶ್ವೇತಾ ಅದನ್ನ ಕೀರ್ತನಾಗ ಹಾಕಿ ಕ್ಲಾಸ್ ಟೀಚರು ಅಂತ ಹೇಳಿದ್ದು ನಾನು UHV ಇವರು ಕೊಡಿ ಕೀರ್ತನನ ಇಲ್ವಲ್ಲ ಯಾವ್ದಕ್ಕೂ ಮಾಡಿಲ್ಲ ಅವ್ರನ್ನ ಇಲ್ಲಮ್ಮ ಇದೆಯೇ ನಾನು CC ಆದ್ರೂ ನನಗೆ ಹೇಳ್ಬೇಕು ಅವ್ರ ನನಗ್ ಬಿಟ್ಟು ಯಾರು ಹೇಳಿದ್ರಂತೆ ಇಲ್ಲವಲ್ಲ ಕೀರ್ತನಾಗೆ ಗೊತ್ತಿಲ್ಲ ಮಾತಾಡ್ತೀನಿ ನೋಡೋಣ ಮಂಡೆ ಯಾಕೋ ಈ ತರ ಆದ್ರೆ ತುಂಬಾ ಕಷ್ಟ ಅಲ್ಲ ಬಂದವ್ರು ಮಾತಾಡಕ್ಕೆ ಹೇಳಿ ಅಷ್ಟೇ ಅಷ್ಟು ಸರಿ ಅದೇ ಎಕ್ಸಾಮ್ ನೋಡಿ ನೀವು ಮಾಡಿ ಹಂಗಾರೆ ನಾಳೆ ಓಕೆ ರೈಟ್ sorry okay so on pause so that the application loses focus but still visible just for a fraction of minutes or maybe for a minute it may be just pause on stop so application is no longer visible so home button so press home button to reply to WhatsApp message so the application YouTube is minimizes the video stops playing automatically so on restart returning to the application switch back so you can tap the YouTube so that recently applications will come up and you can on destroy so the application is cleaned up so swipe away so when you open the YouTube so it won't show the recent so it will be everything is new so that's it from my end for today's session so hope what we discussed is clear have any doubts or clarifications please let me know I'll answer your questions